Welcome back to my channel, everyone. Sri Tips here, and what we have today is some white gold that we're going to refine in this video. White gold is an alloy of pure gold with white metals alloyed with it, like zinc, silver, nickel, and or palladium. That's a watch case there, and it has the same exact gold content as yellow gold, but they just leave the copper out of the gold and add more white metals such as zinc, silver, palladium, and or nickel. So what we'll do is we'll get all the stones out of these pieces, and we'll get this all cleaned up and ready to refine. As you can see, there's some decent diamonds in here, and we're going to take all those out and get this all ready to refine into pure gold. What I'm doing here is removing all of the non-gold material, including the stones. I saved the stones, I saved the diamonds, I put those up, and we'll clean those up, and we can probably try to resell those to someone who needs a diamond missing out of a piece of jewelry. Got everything sorted out now, and I decided to save these two pieces. That's a nice 14K diamond ring with five quarter carat diamonds. And this is a nice pendant with some nice clear diamonds in it. And maybe we'll offer these for sale on my eBay site. These are all the diamonds that I removed from everything. And what I'll do is I'll screw this together. It's a little screen. And we'll put this in the ultrasonic and clean these up real good. And then I save these white gold catches for the backs of earrings down here. And I'll save those and put them up. And maybe if someone loses something like that, I can sell them a replacement. Here's our carat gold sorted out, ready to refine. There were some other pieces in there from a previous refining. Go ahead and dump these little crumbs that have accumulated on our see all that stuff in there? I don't know if you can see it well or not, but there's little bitty crumbs, and we're going to try to get this down into our bins here so we can include that in the refining. $14K stuff. $86.9 grams. Here's the 10K stuff. That's 14.5 grams. Here's our white gold. What we need is 120 or 119.1 grams of sterling silver to quart this gold. Estimated yield from this group will be about 56.6 grams of pure gold. And over here I've got some sterling silver weighed out. I'm going to use this sterling silver up here. It's 121.6. That's close enough. So we're going to go out and we're going to quart this gold with this sterling silver now out on our melt table. Here we go. Someone recommended these glasses. They're for working with molten glass, and they're perfect for this kind of work. Gonna rinse all the tap water off of here, because our next step is to remove the silver and base metals with nitric acid. And we don't want a bunch of chlorinated tap water in there with our gold to avoid forming silver chloride. Okay, here's our gold. This is our unquarted gold. Now that we've added additional silver by alloying sterling silver with the white gold, we now have an alloy that's about 25% gold and the rest 75% silver and base metals. So now, with that alloy, we can use nitric acid to pull all the silver and all the base metals that we just added, plus the silver and base metals that was already in the karat gold. So what I'll do is I'll put this on time lapse now. And back here I have a silver jar. It's full of sterling silver. And what we'll do is pour off these nitric boils into this jar. And then any residual nitric acid that comes off of this reaction will get consumed by the sterling silver that's already in our silver jar over here. So I'm going to put it on time lapse now. And we're going to go ahead and start pulling the silver and the base metals out of this unquarted gold. I can tell by the color of this liquid in here now that all of the silver and all the base metals have been removed. You can see it's pretty much colorless. We've completed the recovery of the gold from the unquarted gold alloy, so we should have nothing but pure gold left in our beaker now. Now it's ready to be refined with aqua regia. This gold here, the bottom of this beaker right now, is fairly close to 3/9 fine, just like it is. But the only way to get it there is to refine it with some aqua regia. So now what we're going to do is add some hydrochloric acid. This is just under 2 ounces. Fill it up to about the 300 milliliter level with hydrochloric acid. Now we're going to cover this up. We're going to set it back up on the heat and start dissolving the gold with aqua regia. You can see we had an immediate reaction because there's some residual nitric acid left on the gold. I'm going to add about a half a milliliter of sulfuric acid, and this should take care of any lead that may be present. It will precipitate out any lead that's in solution as a lead sulfate, and then we can filter it out later on. Initially here is about 30 milliliters of nitric acid. And that should be able to get us in the ballpark to get this this amount of gold dissolved quickly. I'm just going to add this right on in and let the gold dissolve in the aqua regia. That took a little while, not very long, to get everything to go into solution. As you can see, there's lots of fumes still being produced. So what that tells me is that we've got excess nitric in that solution. So we're going to boil it down now until all those fumes disappear. I've got some ferrous sulfate here. I've got some already prepared and ready to be used for precipitation. we're going to use this, but I'm going to prepare a little bit more to make sure that we've got enough when we go to do the precipitation. And someone had asked, what criteria do I use to determine when to use the ferrous sulfate? And the answer is, in this particular case, I've got some platinum group metals in that gold, because white gold is a known carrier of platinum group metals. So let's go ahead and put some water in here first. Distilled water. Turn the stir bar on. And now what we'll do is start adding some ferrous sulfate. Add a little heat to help it dissolve. I'm going to green this up with a little bit of hydrochloric acid. Okay, the nice thing about the ferrous sulfate is that it will only drop the gold. And this is prudent in this case because we're refining white gold. And chances are high that there may be a little bit of platinum group metals in solution with the gold. So the ferrous sulfate won't drop the platinum group metals. They'll get left behind in the solution. Whereas if we used sodium metabisulfite, it will bring down traces of platinum group metals if present. The drawback of using ferrous sulfate is it's kind of a pain to use because you got to filter it. Sodium metabisulfite, on the other hand, you just dump it in, spoon it in, and you're done. But in this case, with the white gold, we're going to use ferrous sulfate to try to precipitate out pure gold. Making progress back here, getting the excess nitric out of that solution. Our solution down here is still cloudy, so we'll filter it again. Got our ferrous sulfate solution cleared up, nice and clear. That's ready for the precipitation. And now what we're going to do, you can see all the fumes have cleared up inside of our beaker here. And that tells us that all the excess nitric has been expelled. Silver chloride is soluble in chloroauric acid solution, more so in a hot chloroauric acid solution. So now we get to see what kind of job we did at removing all the silver out of here. If I can zoom in on this thing. If this turns cloudy when I put this ice in here, it means there's a whole bunch of silver chloride remaining in this solution, because the silver chloride will come out of solution as you cool it off. It crashes out. So let's see what happens here. Let's put the ice in. You can see it's starting to come out of solution there. A little bit. Not a whole lot, but enough to, you can see it turning cloudy. That is the silver chloride precipitating out as the temperature drops in that chloroauric acid solution. Here you can see the trash that the filter has removed from our liquid. This piece here is probably a platinum setting that didn't dissolve in there. But now that this filter is loaded up, what we can do, you'll notice that the solution down here is a little bit cloudy. So what we'll do is go ahead and set this up and filter the solution a second time through the same filter paper. Now that it's loaded up, it should be able to get most of the cloudiness out of this solution. Here you can clearly see the difference that a second pass through the same filter makes on clearing up the solution. This is our original solution. It's cloudy. Now it's nice and clear after we've passed it through the same filter a second time. Our solution cleared up very nice, crystal clear. And here's all the junk in the filter. So what we're going to do, I know that's silver chloride in there, so rather than try to rinse the gold that's in here down into our main solution, what I'll do is put it on a separate funnel, and we'll rinse the funnel into a separate flask, and so we don't put any silver chloride back into our main solution over here, because we know silver chloride is soluble, slightly soluble in water. So we're just going to set it back here out of the way, and I'll add some water back here and rinse the rest of the gold down into this flask, and then we'll add this rinse in here down into our waste container, and we can recover the gold later. Okay, here's a clean beaker. What we'll do now is pour our gold solution into this clean beaker. Look at that, crystal clear. I always forget to do this. It's a good idea to get a little bit of the solution on a piece of filtered paper and then test it with Stannous chloride to make sure that we've got gold in solution. You can see that dark stain verifies that we in fact have gold in solution. Let's get our ferrous sulfate from back here. It's nice and clear now. And what we'll do is go ahead and precipitate out our pure gold with this ferrous sulfate that we prepared earlier. Here we go. I'm going to dump it right on in and precipitate out the gold. Just as I suspected, I didn't have enough, so I've got some more ferrous sulfate solution that I prepared earlier. We're going to go ahead and dump this in now and complete the precipitation. Here we go. There we go. I can see the gold coming out of the solution now. See that? Nice. Give this a stir. get in here and get another Stannis test. Make sure we've got all the gold precipitated now. Let's see what this looks like. Oh, we still got lots of gold in solution. I didn't make enough ferrous sulfate, so now I got to prepare some more. This is probably going to take another hour to get all this done because I got to filter everything. And I was trying to get this video posted this evening. So, here we go. Let's see what we got going on in here. And we got a dark stain. Some nice crystals of gold forming inside the beaker there. I don't know if you can catch that on the camera. Fairly dazzling, sparkly gold crystals. Let's see what happens with this amount of ferrous sulfate that I have here. I'm gonna add this right on in. Let's give this a stir. Just did another test. I can see some green coloration going on. We might be looking at some platinum group metals in solution here. Yeah, I should have known better than to expect to get a video completed for publication on Friday night. I should have known better. Knew I was going to have some problems. Alright, I think we've got all the gold to come out of solution now. Alright, let's see if we can get this waste solution off of here. Get this solution to add to our waste container. I'll set this off to the side for right now. Here's the little bit of liquid that we rinsed out of the filter. We're going to add this right into our waste container. It'll precipitate out on the precipitants that are in the waste solutions, settle to the bottom of the container, and then we can recover it later. Here's the gold down in the bottom of the beaker. Yeah, so what we're going to do now is rinse this over and over, get all the chemicals rinsed off, and give it a hydrochloric acid boil. Adding some hydrochloric acid. Now we'll cover it up, set it up here on the heat source, and try to boil all the ferrous sulfate out of there with hydrochloric acid. Nothing. No metals in solution. It's all ferrous sulfate. Looks just like gold in solution. I'm going to dump off this hydrochloric acid and then rinse it over and over with some hot distilled water. Going to add some more hydrochloric acid. Now we'll set it up on the heat again and give it another boil in hydrochloric acid. The solution is nice and colorless now, so that's a good indication that we've got all the ferrous sulfate rinsed off out of there with these hydrochloric acid boils. So now what I'm going to do is I'll dump off that hydrochloric acid boil into my waste container over here, and then I've got some hot water, and we'll rinse the gold over and over with some hot distilled water. See if we can get our gold down into this melt dish. We're going to take it over here to the melt table and melt this up in ink. Here's our little gold bar that we just poured. Looks pretty good. Got a nice shape to it. I think the key to getting a nice shape like that is getting that mold real hot. It's got a little bit of contamination on the surface like the other bar did because we're using an old melt dish. That melt dish has been in service for a year. Let's see what we're expecting here. We're looking for 56.6 grams from this white gold scrap. Let's see what we got for an actual yield here. 57.9. So a little bit more than expected, and that's okay. We'll take it. All right. That will conclude the video. Thank you for watching.